Implementation of DJI's AI-driven flight systems by Q1 2026. Overview. DJI, a leader in drone technology, has announced an ambitious plan to implement its AI-driven flight systems by Q1 2026. This initiative is structured into 4 distinct phases with a total budget allocation of $5 million aimed at enhancing autonomous navigation capabilities across key sectors: cinematography, agriculture, and disaster management. This report provides a comprehensive overview of the project, detailing its phases, expected outcomes, and strategic importance. Project phases. Phase 1: Research and Development (R&D). Timeline: Q1 2024, Q3 2024. The project will kick off with an extensive R&D phase focused on refining AI algorithms. The objectives during this stage include improving flight stability, developing advanced algorithms to ensure smoother and more reliable flight operations, obstacle detection, creating sophisticated systems capable of detecting and avoiding obstacles in real time, data processing, enhancing the drone's ability to process data quickly and efficiently, which is crucial for autonomous decision-making. This foundational phase is critical as it sets the groundwork for the more advanced features that will be integrated into the systems during subsequent phases. Phase 2: Pilot Testing. Timeline: Q3 2024, Q1 2025. Once the R&D phase is completed, DJI will move to pilot testing. This phase will involve controlled environment testing. Drones will be tested in various scenarios to evaluate performance. Collaboration with industry partners. DJI will work alongside cinematography, agriculture, and disaster management experts to gather valuable insights and data. Safety assessments. Ensuring the drones meet safety standards and performance benchmarks is a priority. Pilot testing aims to validate the system's reliability and effectiveness in real-world applications before broader deployment. Phase 3: Full-scale deployment. Timeline: Q1 2025, Q4 2025. Following successful pilot testing, DJI will implement full-scale deployment of the AI-driven flight systems. Key activities during this phase include integration of feedback. The insights gained from pilot testing will inform final adjustments to the technology. Sector-specific adaptation, tailoring the systems to meet the unique needs of cinematography, agriculture, and disaster management. Training and support, providing education and resources to users to ensure they can effectively utilize the new systems. The focus will be on rolling out the technology in select markets where it can provide the most significant impact. Phase 4: Post-deployment review and scaling. Timeline: Q4 2025, Q1 2026. The final phase involves a thorough review and scaling of the project. This phase includes monitoring performance, continuously assessing the system's performance and user satisfaction. Iterative improvements, making ongoing enhancements to the technology based on user feedback and advancements in AI. Exploring new applications, identifying potential new sectors for drone application. Broadening the impact of the technology. This phase ensures that the systems remain relevant and continue to evolve with changing technological landscapes and market needs. Use cases and applications. Cinematography. AI-driven drones are set to revolutionize cinematography by autonomous shot capture, enabling drones to autonomously execute complex shots, reducing the need for human pilots and enhancing creative possibilities. Precision filming, utilizing AI to stabilize shots and optimize camera angles for professional-grade video production. Agriculture. In agriculture, these systems will provide significant improvements by crop surveillance, offering autonomous surveying capabilities to monitor crop health and growth. Resource optimization, analyzing data to optimize water and fertilizer usage, thereby increasing efficiency and productivity. Disaster management. For disaster response, AI-driven drones will rapid assessment, quickly assess damage in disaster-stricken areas, providing crucial data to emergency response teams, improve situational awareness, enhancing the ability of responders to understand the situation on the ground, facilitating more effective response strategies. Strategic importance. The successful implementation of DJI's AI-driven flight systems is poised to offer substantial benefits across multiple sectors. The phased approach ensures that technology is thoroughly tested and refined before deployment, mitigating risks and enhancing user trust. Additionally, the focus on AI underscores the growing importance of intelligence systems in modern technology, marking a significant step forward in drone capabilities. Key takeaways. DJI's initiative involves a structured four-phase plan with a $5 million budget to enhance AI-driven drone technology. The project spans from R&D to post-deployment review, ensuring comprehensive development and user integration. Target sectors include cinematography, agriculture, and disaster management, each set to benefit from advanced autonomous navigation capabilities. Conclusion. In conclusion, DJI's implementation of AI-driven flight systems represents a significant advancement in drone technology. The strategic phased approach will not only enhance operational efficiency across various sectors but also set a benchmark for future developments in autonomous systems. With a clear timeline and defined objectives, DJI is well positioned to lead the way in integrating AI into drone operations, ultimately transforming how industries operate and respond to challenges. The implementation of DJI's AI-driven flight systems by Q1 2026 is an ambitious project that highlights several counterintuitive aspects regarding the application and development of drone technology. Here are some notable counterintuitive points derived from the content. 1. Budget allocation versus scope of technology. At first glance, a $5 million budget for such an expansive project might seem insufficient given the complexities associated with AI autonomous navigation and the integration of these systems across multiple sectors: cinematography, agriculture, and disaster management. One might expect a larger investment for such advanced technology. However, this budget reflects a strategic focus on methodical development rather than an all-out financial commitment. This suggests that efficiency and targeted spending can lead to significant advancements without the need for excessive funding. 2. Phased rollout versus immediate implementation. The decision to implement the project in 4 distinct phases contrasts with the common expectation that technology should be rolled out as quickly as possible. In many industries, there is a rush to market, but DJI's structured method prioritizes thorough testing and feedback. This approach may appear slower but ultimately leads to more reliable and safe technology, which is especially crucial in sensitive applications like disaster management, where lives may depend on the technology's effectiveness. 3. Focus on feedback mechanisms. The project emphasizes a post-deployment review phase where ongoing monitoring and enhancements will be made based on user feedback, which might seem counterintuitive in a field where cutting-edge technologies are often expected to be perfect from the start. This approach indicates a belief that real-world usage will unveil insights that lab testing cannot, thereby improving the final product significantly. 4. Use of AI in creative industries. The application of AI-driven drones in cinematography may seem paradoxical given that creativity is often considered a uniquely human trait. The use of autonomous systems for capturing complex shots challenges the traditional notion that creativity must be fully human-driven. This suggests a potential shift in how we perceive the role of technology in artistic fields, where automation can complement human creativity rather than replace it. 5. Agricultural efficiency versus job displacement. While the use of AI drones in agriculture is expected to significantly enhance efficiency and resource optimization, there is a counterintuitive tension regarding the potential displacement of agricultural jobs. Many might assume that advanced technology leads to job losses. However, improved efficiency could also result in new opportunities in tech-driven agricultural roles, suggesting that technology might transform rather than eliminate employment in the sector. 6. Regulatory compliance as an afterthought. Some sources highlight the necessity for regulatory compliance, suggesting that navigating legal frameworks may delay timelines. It is counterintuitive that a technologically advanced initiative might face hurdles due to bureaucracy, implying that innovation does not always proceed in a linear fashion and that external factors can significantly impact technological advancement. 7. Disaster management's reliance on technology. The notion that drones equipped with AI can quickly assess disaster-stricken areas raises questions about the reliability of technology in crisis situations. While one might assume that human judgment is superior in emergencies, this initiative posits that AI can enhance situational awareness and data collection, potentially leading to faster and more informed decisions. This presents a paradigm shift in how we view the role of technology in critical response scenarios. These counterintuitive findings underscore the complexities and nuanced considerations involved in the implementation of DJI's AI-driven flight systems, suggesting that technological advancement is not simply about rapid development and deployment but involves a careful balance of innovation, practicality, and adaptability to real-world conditions. The report on DJI's implementation of AI-driven flight systems by Q1 2026 presents a structured approach to enhancing drone technology across various industries. While the summary offers a clear outline of the phase's budget and anticipated outcomes, there are several critical elements within the report that may be overlooked by most readers, which are significant for understanding the full implications of this initiative. 1. Importance of AI algorithm refinement. Significance. The emphasis on refining AI algorithms during the R&D phase is crucial. Many people may focus on the end applications, cinematography, agriculture, and disaster management, without fully appreciating how foundational the AI algorithms will be for the overall success of the project. These algorithms will dictate the drone's ability to navigate complex environments, detect obstacles, and process data in real time. Why it matters. A strong underlying algorithm is essential for ensuring safety and reliability. If the algorithms are not adequately developed, the drones could misinterpret their surroundings, leading to accidents or ineffective data collection. Moreover, the adaptability of these algorithms to various environments will determine how well they can perform in diverse applications, which is particularly important in unpredictable scenarios like disaster management. 2. Pilot testing collaboration. Significance. The report mentions collaboration with industry partners during the pilot testing phase, yet the implications of these partnerships are often underestimated. The success of pilot testing hinges on effective collaboration, allowing for real-world feedback that can lead to crucial adjustments in drone operations. Why it matters. Collaboration can help identify unforeseen challenges and ensure that the technology is tailored to meet industry-specific needs. This partnership model not only enhances the reliability of the deployment but can also foster innovation, as partners may suggest improvements based on their experiences. Furthermore, these collaborations could pave the way for future business opportunities and establish DJI as a leader in cross-industry drone applications. 3. Regulatory compliance considerations. Significance. The report briefly mentions the need for regulatory compliance, which is a critical factor that can drastically influence the timeline and scope of the project. While many readers may overlook this aspect, it could have far-reaching consequences. Why it matters. Regulatory frameworks surrounding drone usage vary significantly across regions and industries. Delays in obtaining necessary approvals or adjustments to comply with regulations could push back the entire timeline. Furthermore, understanding and navigating these regulations is essential for the successful deployment of AI-driven drones, particularly in sensitive areas like agriculture and disaster management, where privacy, safety, and environmental concerns are paramount. 4. Post-deployment review and continuous improvement. Significance. The final phase emphasizes ongoing monitoring and user feedback for continuous improvement, an aspect that some may dismiss as a routine process. However, This phase represents an evolving commitment to technology enhancement that is often overlooked in many projects. Why it matters. The post-deployment review is crucial for identifying weaknesses and areas for enhancement in the technology. This iterative process allows DJI to adapt the drones to changing user needs and technological advancements, ensuring they remain competitive in a rapidly evolving industry. Moreover, active engagement with users can lead to innovation and new applications that were not initially considered, potentially expanding the reach of DJI's AI-driven systems. 5. Diverse use cases beyond initial applications. Significance. While the report specifies cinematography, agriculture, and disaster management as the primary sectors, the potential for AI-driven flight systems to extend into other industries is significant yet often underappreciated. Why it matters. The fundamental technology being developed could be applicable in numerous fields such as infrastructure inspection, environmental monitoring, and wildlife conservation. As the technology matures, its versatility could become a key selling point, opening up new markets and revenue streams for DJI. Recognizing this potential early on could encourage strategic partnerships and investments in related sectors. 6. Budget allocation and financial considerations. Significance. The $5 million budget allocation is a figure that may seem modest compared to the scale of the project. Many might overlook the implications of budget constraints on the quality and scope of development and testing. Why it matters. A limited budget can restrict the depth of R&D, the extent of pilot testing, and the robustness of post-deployment reviews. It is crucial to consider how budgetary limitations could impact the overall success of the initiative. Moreover, if the initiative proves successful, there may be opportunities for additional funding to expand the project, which could influence future technological advancements. 7. Potential impact on employment and industry dynamics. Significance. The implementation of AI-driven flight systems could have significant implications for employment in the sectors targeted by DJI, yet this aspect is often overlooked in technical reports. Why it matters. As drones become more autonomous, the demand for manual pilots may decrease, leading to shifts in job roles within cinematography and agriculture. Conversely, there could be a growing need for specialists in drone technology, data analysis, and maintenance. Understanding these dynamics is essential for stakeholders in these industries to prepare for workforce transitions and ensure that employees are equipped with the necessary skills to thrive in an evolving landscape. Conclusion. In conclusion, while the report on DJI's AI-driven flight systems provides a structured overview of the implementation plan, several critical aspects warrant deeper consideration. From the foundational importance of AI algorithm development to the implications of regulatory compliance and the potential for diverse applications, these elements are significant in understanding the project's full impact. Recognizing and addressing these aspects will not only enhance the initiative's chances of success but also ensure that it meets the evolving needs of various industries in a rapidly changing technological environment. 1. Four-phase implementation strategy. The structured four-phase approach to implementing DJI's AI-driven flight systems is critical for ensuring a systematic and thorough development process. This methodology includes research and development, R&D, pilot testing, full-scale deployment, and post-deployment review and scaling. Each phase serves a distinct purpose. From refining AI algorithms to validating performance in real-world scenarios and gathering user feedback for continuous improvement. This incremental approach minimizes risks and allows for adjustments based on empirical data, ensuring that the final product is both reliable and effective across the targeted sectors of cinematography, agriculture, and disaster management. 2. Sector-specific applications. The focus on key sectors, cinematography, agriculture, and disaster management, highlights the versatility and potential impact of DJI's AI-driven flight systems. In cinematography, drones can autonomously capture intricate shots, enhancing creative possibilities for filmmakers. In agriculture, these drones can optimize resource usage and monitor crop health, leading to increased efficiency and sustainability in farming practices. For disaster management, AI-equipped drones can rapidly assess affected areas, providing critical information that supports emergency response efforts and accelerates recovery. The identification of these specific use cases illustrates not only the technology's applicability but also its potential to address significant challenges in these industries. 3. The budget allocation and resource management. The $5 million budget allocation for this initiative underscores DJI's commitment to advancing drone technology through the lens of AI integration. This budget needs to be efficiently managed across the 4 phases to ensure that resources are appropriately allocated for R&D, pilot testing, deployment, and post-deployment activities. The financial commitment also reflects the anticipated return on investment through enhanced capabilities and market competitiveness in the rapidly evolving drone industry. Effective budget management will be essential for addressing potential regulatory compliance costs and unforeseen challenges during implementation. 4. Regulatory compliance and market challenges. Navigating the legal and regulatory frameworks surrounding drone operations is a significant consideration that may impact timelines and the overall success of the project. While the implementation plan is ambitious, adherence to regulations in different regions is paramount. This aspect introduces complexities that could affect the deployment of AI-driven systems, especially in sectors like disaster management where rapid response is essential. Addressing regulatory compliance not only ensures safety and operational legality but also fosters public trust in autonomous drone technologies. Furthermore, understanding the challenges posed by market competition and technological advancements will be vital for DJI to maintain its leadership position in the drone industry as it rolls out these innovative systems. These 4 points offer a comprehensive overview of the strategic, technological, financial, and regulatory considerations that will shape the successful implementation of DJI's AI-driven flight systems by Q1 2026. 1. The Manhattan Project 1942–1946. The Manhattan Project was a research and development project during World War II that produced the first nuclear weapons. Led by the United States with support from the United Kingdom and Canada, it aimed to harness nuclear fission to create atomic bombs. The project was divided into several phases, including basic research, technology development, and full-scale production, with an initial budget of approximately $2 billion, around $25 billion in today's dollars. The outcome was the successful detonation of atomic bombs in Hiroshima and Nagasaki, which had profound implications for warfare and international relations. 2. Apollo Program 1961–1972. The Apollo program was a series of space missions conducted by NASA with the goal of landing humans on the Moon and bringing them safely back to Earth. It was initiated in response to the Soviet Union's advancements in space technology. The program was executed in multiple phases, beginning with uncrewed missions to test the technology, followed by crewed missions leading to the historic Apollo 11 landing in 1969. The total budget for the Apollo program was approximately $25.4 billion, equivalent to over $150 billion today. The program not only achieved its primary goal but also advanced technology in various fields, including computer science and materials engineering. 3. Human Genome Project 1990–2003. The Human Genome Project (HGP) was an international scientific research project aimed at mapping and understanding all the genes of the human species. It was organized into phases, starting with the identification of the genome's structure and leading to the sequencing of the entire human genome. The project had an estimated budget of around $3 billion and involved collaboration among numerous research institutions worldwide. The HGP was completed ahead of schedule in 2003 and has had a lasting impact on fields such as genetics, medicine, and bioinformatics, paving the way for advancements in personalized medicine and genetic research. Future outlook: predictions for the implementation of DJI's AI-driven flight systems by Q1 2026. As DJI embarks on the implementation of its AI-driven flight systems by Q1 2026, several predictions can be made regarding the potential impact and advancements in the realms of cinematography, agriculture, and disaster management. This analysis considers technological, economic, and social factors that may influence the future landscape. 1. Technological advancements. Enhanced autonomous capabilities. By 2026, the AI algorithms developed during the R&D phase are expected to significantly enhance the autonomous capabilities of drones. These advancements will likely lead to more sophisticated obstacle detection and avoidance systems, allowing drones to navigate complex environments with minimal human intervention. The ongoing refinement of these systems will pave the way for drones to operate effectively in various conditions, from urban settings to rural landscapes. Integration of machine learning. Machine learning will be a core component of DJI's AI systems, enabling drones to learn from their environment and improve their operational efficiency over time. This predictive capability will allow drones to make real-time decisions based on historical data and environmental variables, enhancing their utility in agriculture for crop monitoring and in disaster management for rapid assessments. 2. Economic impact. Cost reduction in cinematography. The adoption of autonomous drones in cinematography is expected to reduce production costs significantly. With AI-driven systems capable of executing complex shots autonomously, filmmakers can save on labor costs associated with manual piloting. This reduction in overhead may democratize access to high-quality aerial footage, empowering independent filmmakers and smaller production companies. Increased agricultural productivity. In agriculture, the deployment of AI-driven drones is predicted to lead to significant increases in productivity. By autonomously surveying crops and optimizing resource usage, farmers can achieve better yields while minimizing waste. This could result in a reduction in the cost of food production, potentially lowering prices for consumers and boosting the agricultural economy. 3. Social implications. Improved disaster response. AI-driven drones will play a crucial role in disaster management by providing real-time data and situational awareness. As these systems are integrated into emergency response protocols, the speed and effectiveness of disaster response efforts are expected to improve. This capability will not only save lives but also aid in the recovery process, allowing communities to rebuild more quickly after disasters. Public perception and acceptance. As the capabilities of drones become more apparent, public acceptance is likely to grow. Initial concerns regarding privacy and safety will need to be addressed through robust regulatory frameworks and transparent communication. By 2026, effective collaboration with regulatory bodies may result in guidelines that ensure safe and responsible drone usage, fostering a more favorable public perception. 4. Sector-specific growth. Cinematography. The film industry will witness a surge in innovative storytelling techniques as filmmakers leverage AI-driven drones for creative shots. These drones will enable new perspectives and dynamic movements, transforming how stories are told visually. Furthermore, the seamless integration of drones into film production workflows is expected to become standard practice. Agriculture. The agricultural sector may see a rise in precision farming techniques where AI-driven drones analyze crop health and provide actionable insights to farmers. This shift towards data-driven agricultural practices is expected to enhance sustainability and food security, addressing global challenges related to population growth and climate change. Disaster management. The disaster management sector will likely evolve with the incorporation of AI-driven drones as essential tools for first responders. These drones can quickly assess damage and locate survivors, leading to more effective resource allocation and response strategies. The collaboration between drone technology and emergency services will foster innovation in disaster preparedness and recovery. 5. Regulatory and ethical considerations. As DJI's AI-driven flight systems come into play, regulatory frameworks will need to adapt to accommodate the new technologies. By 2026, it is anticipated that comprehensive regulations addressing airspace safety, privacy concerns, and operational guidelines will be established. This will ensure that the benefits of AI-driven drones are realized while maintaining public trust and safety. Additionally, ethical considerations regarding data usage and privacy will become increasingly important. Stakeholders will need to engage in discussions about responsible drone usage, ensuring that technology serves the public good without infringing on individual rights. Conclusion. In summary, the implementation of DJI's AI-driven flight systems by Q1 2026 holds significant promise for transforming cinematography, agriculture, and disaster management. With advancements in technology, economic benefits, and positive social implications, these systems can lead to enhanced operational efficiency and creativity across sectors. However, careful attention to regulatory and ethical considerations will be crucial to ensure the responsible integration of this technology into society. As DJI progresses through its phased approach, the outcomes will pave the way for a future where AI-driven drones play an integral role in various industries, setting new standards for innovation and operational excellence.